In today's video, we are going to find the equation of the tangent of the parabola y squared equal to 4x at the point x equals 1 and y equals 2. The next step is to find dy by dx at the point 1, 2. We can do this by implicit differentiation. Differentiating with respect to x, then we have dy squared by dx equals to 4. Now by the chain rule, we can first differentiate y squared with respect to y, then multiply by dy by dx. Rearranging gives dy by dx equals to 2 over y. Now we want the gradient of tangent at the point 1, 2. Substituting y equals 2 gives dy by dx to be 1. Now we want to find the equation of the tangent. We have the gradient, hence we only need to find the y-intercept. Substituting x equals to 1 and y equals to 2 gives us c equals to 1. So the answer is y equals to x plus 1. Implicit differentiation is not the only way to find dy by dx. Notice that the parabola is a function of y but not a function of x. Because a single value of x can be mapped into two values of y. This is a one-to-many mapping. However, since we are only considering the point 1, 2, we can consider only the portion of y greater than or equal to 0. In this case, we can express y as 2x to the power a half. Differentiating gives dy by dx equals to x to the power negative a half. The rest would follows in the same way. Implicit differentiation is a tool for finding gradient of tangent at a certain point for an implicit function. An implicit function is a function of more than one variables, which is impossible to make one of the variable to be the subject of the equation. For example, like this example, even though we can express y as plus or minus 2 square root x, this is not a function, and hence it is not differentiable. However, we can define a range where it is a function such that we can differentiate it. To generalize this concept, we can define a neighborhood around a point where y can be expressed in terms of a function of x. Under this case, we can use implicit differentiation, which allows us to differentiate terms of y using chain rule. The condition for this requires a higher level of knowledge. For an implicit function in the form r of x, y equals to 0, then in order to create a neighborhood around a point on the curve, and hence use implicit differentiation, the partial derivative of r with respect to y is non-zero at this point. This is a good way to end this video. If you like this video, feel free to leave a comment, like the video and subscribe to the channel. I shall be uploading revision questions with flashcards every day on common high school topics, especially algebra and calculus. See you next time.